What's up? Welcome back. In this episode, you'll see how to solve day 11 in the Advent of Code for 2023. This one is called Cosmic Expansion. Have you ever been to a planetarium or an observatory and gotten to lay down and pretend that you're flying out into the universe? The Boston Museum of Science in Massachusetts has this really amazing experience where you can go to the planetarium, and one of the shows is they'll kind of like take you on a tour through the universe, and you can see all these different galaxies and how they're spread out. And what's really cool is that our exercise today is about space and galaxies and cosmic expansion. And so we are given some input, and our input is an image that contains some galaxies out in the distance. So each of these pound signs represents a galaxy, and each dot represents just empty space. And what we're going to do is we're going to start with this input here, and we need to find the shortest path between every pair of galaxies. So we're going to go from this galaxy to this one, and this one to this one, and this one to this one, and so on and so forth, each unique pair. But part of the challenge is that any row or column in our image actually needs to be expanded. And every single time that we find a row or a column that is all dots, that represents a space between galaxies that's twice as big as the result of cosmic expansion. So when we took the image, cosmic expansion happened, and it's actually twice as big as that. So we need to take that input and explode it out. Where there's spaces, we need to make it bigger. So this is what we would get from this input. So taking this first input that has maybe 10 across, and we're going to end up with this output that has 13 across or something. So each of these arrows or these carets represents a row or a column that needs to be expanded. Then once we have the expanded universe, we can label each of the galaxies, and we want to find for every single pair, what is the shortest distance between galaxies? And the distance between galaxies is just going to use up, down, left, and right. So if you have a keen eye, this is just like the rise and run or whatever. The number of times that we go to the right or the number of times that we go down is going to be the same if we go all the way across here and then down, or all the way down and then all the way across. We're going to end up with the same number of steps in our path. What's really nice about that is we can use this thing called the Manhattan distance, which is just the absolute value of this location's x minus this location's x plus the absolute value of this location's y minus this location's y. And then you end up with the number of steps that are here. Let's jump in and grab this input. We'll crack open main.rb and get to work. First, we want to break out input into a grid. So we're going to say data is equal to input.each line.map chomp. And then we'll say grid is data.map line to chars. Sure. P grid. And that's going to give us an output that looks like this. Okay. So the first thing we want to do is find which rows and which columns are empty. So we're going to say empty rows is grid.map with index row and x. And we're going to say if the row is all periods, then we want to return x. Now, if we do this, we end up with some nils, right? P empty rows. Okay, empty rows. Did I spell it wrong? What's going on here? So here our empty rows output is nil, nil, 3, nil, 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 7. I know what you're thinking, and I know what GitHub Copilot is thinking. Dot compact, that'll remove the nils. But what I want to show you was this method in Ruby called filter map, which is just exactly for this purpose. Filter map will only, it will just exclude the nils for you automatically, which is so handy. Also, did you know that you could pop with index onto the end of these enumerables and then you just get an index for free? Amazing. Okay, so that's our empty rows. Now let's find our empty columns. Is going to be basically the same thing, but we're going to transpose the grid and filter map again, and with index. And if all the columns are dots, then we should end up with some empty columns. So we'll we'll print out empty rows and empty columns just to make sure that we have something that works here. So 3, 7 should be our empty rows. So 3 and 7 are our empty rows. And then it should be like 2, 6 and 9-ish or something like that. 2, 5 and 8. That's roughly correct. Okay. Now what we want to do is we want to go through our grid and expand the grid. If we want to start expanding the number of rows or the number of columns, we don't necessarily want to just iterate in order from top to bottom, because then our index is going to shift. So for instance, if we start with this number 3 and we insert a row below it, then our index of our last one gets moved forward, right? So if we're iterating over 3 and 7 and we want to insert a new row here, if we insert a row after 3, then 7 is no longer the correct pointer at the next row that needs to be expanded. So the way I solve this is just to go backwards. So if we start with row 7 and we pop in a row after 7, and then we go to 3 and we pop a row in after 3, then we should be good. So we're just going to go through the rows and columns, the empty rows and empty columns backwards. And that will tell us where we need to insert a row. So now we want to say grid.insert at row some new empty row. So array.new, that is the same length as the first grid. And then we want to do the same thing for columns. So empty calls.reverse.each do column. And then we're going to say grid.insert column. And that I think this is opposite. This one, we want the length of the column to be equal to, oh no, that was right. Okay, yeah, the length of the column should be equal to the length of the thing. And this one should be the length of any given row. Okay, so if we go through the grid and we print out row.join, what does it look like now? Oh, this looks funky. Okay, this is wrong. Okay, so maybe this was right. Am I backwards here? There we go. Now we have a square, but it has this extra dangly guy right here. What is the deal with that? That seems wrong. Okay. What is going on? Row.reverse, so p row. And let's see, row is this one. And oh, grid dot. Okay, so then we need to actually go over, right? We need to go over each of the rows, and for each row, we need to insert into the column that is missing. Okay, all right, there we go. All right, let's just do some back of the napkin double checking here to see if this looks like the same as what we have in the example. So I'm going to just search for that. Okay, so this is when the rows are twice as big. That looks correct, and that matches that. Okay, and then the bottom row should be correctly this. Okay, great. So now we have an expanded grid. So we've expanded the rows and columns to be twice as big. Cool. Now what we want to do is find all the galaxies. So where's all the galaxies on the list? So comment out our printing. And we want to find some galaxies. So galaxies are equal to, we want to go through the grid and we want to find the cells where the cell is equal to a pound sign. And if it is a pound sign, we're going to keep track of the X and Y. And now if we print out galaxies, we should get some list of galaxies, 0, 4, 1, 9, 2, 0, et cetera, et cetera, et cetera. And that looks pretty good. We want to grab each pair of galaxies and figure out the shortest distance between those two galaxies. There is a method in Ruby that you can call on array. So consider an array like 1, 2, 3, 4. We can say a dot combination of 2. And this will give us an enumerator. If we do 2a, this will give us all of the combinations of 2 elements from this array without repeating a combination. So this gives us, it's missing any duplicates. So 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, and 3 to 4. And then this is all the different combinations of all the different elements that are here. We can do the same thing with our pairs of galaxy or our galaxies. So we want to do galaxies dot combination of dot each do X and Y. And what I want to do is build a dictionary that looks like this, where we have some galaxies position. So 0, 0 is the from galaxy, and then 1, 1 is the to galaxy, and then the distance would be 1. And then what we can do is we can go through and figure out what are all the distances between all these galaxies, and we can add up the values of this dictionary, and that'll at least kind of like let us keep track of the distances between each one. So if we have these combinations of 2, then and we map over them, we can get back. Yeah, let's actually keep these combined as like Galaxy A and Galaxy B. And then we can make our first element of this array A comma B, and the second element of the array could be distance of A to B. Okay. And for now, we'll just make a method called distance that takes in A and B and returns 1, just so that we can start to get an idea of what this actually looks like. So we'll say our result is something, p result, and we'll run this. Okay, so 0419 goes to 1, 0420 goes to 1. Okay, great. So now we actually have to implement this shortest distance method. Okay, so we're going to take in A and B. For now, we can just implement the shortest distance as being like AX, AY is equal to A, and then BX, BY is equal to B. So we're destructuring the X and Y locations for the galaxy. And then what we want to do is take the absolute value of AX minus BX. That's going to give us, the absolute value of the X coordinates subtracted, or the difference of the Y coordinates subtracted. We're going to add the absolute values, and that should give us the distance. So if we run this, so from 04 to 19, we get 6. So let's actually print our grid out again and just see from 04 to 19, it gets 6. So 1, 2, 3, 4, 5, 6. So that looks correct. And then let's look back at the example here. And it says this path has length 9 because it takes a minimum of 9 steps to go from this location to this location. So this 5 is on 0, 1, 2, 3, 4, 5, 6, 1. So we're going 6, 1 to 11 something. So if we run this again, our 6, 1 to 11, 5 is 9. So this is the answer in the example. Now what we can do is add up these distances. So we might actually be able to just say inject sum, and then we'll take A and B. And then maybe we don't actually even need a dictionary. We can just say sum plus distance of A to B. And that didn't seem to do what we thought it was going to do. Oh my word, 374. So 374 is, look at that. That is the answer from the example. So in this case, we're not actually keeping track of that dictionary like I talked about. We are just figuring out the distance and printing it out. All right, like always, let's grab our puzzle input, pop it here at the bottom, and use this. Okay, and then we're going to make our data be data.readlines.map chomp and run it against our actual input. And what do we get? We get a whole lot of nothing. Okay, so we don't want to print out the grid anymore. And we don't actually need this one. What do we get for the result? 9556896. Okay, let's see if that matches. Hey, that's our answer for part 1 of the puzzle. Amazing. Okay, what have we got going on here? We're just finding the distance between A and B. We're adding that up and getting some result back that we're then printing out. So we've got our distances between galaxies. We've expanded the galaxies. Let's head on to part 2. Okay, part 2. The galaxies are actually much older and thus much further apart than the researcher initially estimated. Instead of expanding the way we did before, now each empty column needs to be 1 million times larger. So every empty row needs to be replaced with 1 million empty rows. Okay, that's a lot of empty rows. I don't think our expansion algorithm is going to work anymore, right? We don't want to go through and make a million by million array, and it would actually end up being like the number of empty spaces, so 6 million by 6 million or whatever array. So we've got to take a different approach here, but we want to somehow expand it by a million. So in the example above, if each row or column was 10 times larger, then the answer would be 1030. So what we want to do is refactor this so that instead of expanding our grid, like instead of doing this empty rows, empty columns, inserting business, we actually don't want to insert, right? We want to use some other approach where we're going to use empty rows and empty columns in order to figure out our distance. So before, let's actually try to make it so that our result is equal to what it was before. If this is the distance of like the galaxies between each other with no expansion, then the expansion would be something like d plus equals the number of rows that are between A and B, and plus equals the number of columns that are between empty columns. So we need to go through the empty columns and the empty rows that are between A and B. How do we do that? I think we want to go. Okay, so in this case, when we're doing the absolute value of A minus B, it doesn't matter whether A or B is larger, right? But we want to iterate in the correct direction, basically. So we need to take the minimum of AX and BX and the maximum, X min, X max, is equal to this. I think, so let's see. So if we have 150 min max, then we get back 1 and 50. And if we have 50 and 1, we get 150. Okay, so min max is going to give us back this 2-element array. We want to do the same thing with y. And then we want to iterate from y or x min up to x max. And we want to say if empty rows include x, then we want to d plus equals 1, right? So as we're iterating over our x's, we want to see if there's any empty rows, and if there are, we want to increase the distance by 1. Because remember, we're trying to get back to our original answer here. And that might need to be that. Okay, let's just replace all these with x with y, and then this is still x. Okay, and then at the end, we want to return d. So let's see if we get the same number. Okay, so we need to pass in empty rows and empty columns as arguments now to distance. So we have those as variables up here, so we can just pass them in down when we're calling this distance function. And now if we run this, we get back 9627156, which was not the same as our answer. It's a little bit higher than our answer. So perhaps we need to go up to, but not including 96. Okay. Oh, you know what? We didn't change this to columns. This shouldn't be empty rows. This should be empty calls. Okay, let's see here. 9556896, 9556896. Okay, so this is like an alternative solution to part 1. So now what we want to do is, instead of increasing it by 1, let's use this sample input and try to increase it by 10. So if it's 10 times bigger, then let's just see if we increase by 10 and we run it. Okay, so we get 1,112, but the answer should have been 1,030. And when we're thinking about doubling, it went from 1, we like replaced 1 with 2. So now we're going to replace 1 with 10. And since in this scenario, we're already counting up the empty row once, we need this to be 10 minus 1, right? So technically, like the original answer was 2 minus 1. So now it's 10 minus 1. And we get back 1030, okay? And if it was 100 times larger, then it would be 8410. So if we make this 100, we should get 8410, and we do. Okay, so now what we want to do is figure out what our puzzle answer is. So we need to make this 1,000,000 times bigger. One really cool thing about Ruby is we can just put these underscores so that our numbers are legible. And we run this, and that is for the example input. So what is it against our input? Huge number, and that is our puzzle answer. Awesome. This was, okay, so this is this pretty fun little solution here. Turns out we actually didn't need to do this insert business, so we'll remove that. We're finding our galaxies. We've got a distance method here that seems to work well, and it supports cosmic expansion for both part 1 and part 2, technically. I guess we could put in a comment here that was like, part 1 would be d plus equals 2 minus 1, just to make it clear that we were doubling in size in that case. This combination method is pretty cool. You can even do like combinations of 3, and that will give you all the different combos of 3. That can be really helpful anytime you want to do combination. Methods like combination, permutation, and like dot product, things like that are really, really useful on the array methods in Ruby. Yeah, thanks so much for watching, and we'll see you in the next one. Cheers.